video, I'm going to lay out the framework for the travel cost model. So the three-step is first you calibrate the travel cost model, then you derive the demand function from that model, then you calculate the consumer surplus. Okay, so let's actually start from the last step, which is the motivation of the whole travel cost model. Let's say if I want to calculate the consumer surplus, which you should be something learned in intermediate micro class. Let's say this is a demand curve. You know that the current price is P0 and the quantity is Q0. So the consumer surplus is below demand curve above the price. So it is a red shaded area. Let's say the consumer demand function is actually dP. So the consumer surplus is just going to be integration of dP over P from P0 to P choke. Okay. Choke price means the point where the demand is for that quantity is 0. So you also get P choke is 0. The one thing I want to point is that here this is kind of a weird notation because I am using Q as my x-axis, but my demand function is actually a function of P rather than a function of Q. So in a normal map, a more normal convention, I will actually flip the P and Q axis, but since this is the more conventional way of micro calculation, so that's the way we set it up. So now the question is, how are we going to trace out the demand curve? And I think this is a part where it gets the travel cost model is ingenious, is that you want to get the variation from different region, the cost that people from different region travel to this area. Why is that important? Now let's say you want to calculate the demand for Yellowstone. Yellowstone charge a flat rate price for everyone to come and enjoy the nice thing. So you only get one quantity and one price. You cannot trace out the whole demand curve. But people travel from Wyoming, where the Yellowstone Park is very different from people who actually travel all the way from New York. Okay, people all the way from New York actually have to spend more money on the cost because they have to travel by either air or by road, and the time they spend on the road, on the travel, is also opportunity cost to them. So actually people have different costs from different area, and you can therefore calculate the demand curve based on the cost. Okay, so that's the key intuition of our travel cost models. So now let's try to write out the travel cost model. Let's say you have region 1, region 2, all the way to region N, and you know the visitor number from each region is V1, V2, and Vn. Okay, you want to use this visitor number as inputs to the demand curve calculation, because the population of each region could be very different. That's something you should bear in mind. Okay, let's say you get 10 person from Wyoming and 10 person from New York. Okay, although they all have the same number of visits, the probability of visit is very different, and that is actually what you are trying to shooting for. Is the ratio of visit, the probability of visit, which is basically what you are trying to do here. Okay, now let's call this P vector. So this is going to be P1, P2, all the way to Pn. This is not price, but the probability of visiting. So that's our y variable. What is our x variable? X variable will be the travel cost from TC1, TC2, all the way to TCN. So travel costs could have vehicle costs. Let's say you want to rent a car, or you own a car but you have to pay insurance. Variable costs, like let's say if you travel by car, you have to pay gasoline. If you travel by air, you have to pay air fee. Opportunity costs, right? The time you spend on the road. If you fly 3 hours to the destination, that's 3 hours you can otherwise spend on valuable activities. So you can get an idea about the typical travel cost from a typical region. Okay, so now you get data, which basically is a pair of PI and TCI. And that's the data. So you want to fit a model that gives you something like, given a specific travel cost, you will actually have you can calculate the probability that they actually will go in there. Well, hypothetical, let's say the model is something like I fit a log model, and now I want to calibrate the demand curve. So first thing is that actually I need to translate log into level price, level probability, because actually cannot multiply log probability with level population. So here I need to do pi, but that is not q yet. We actually need to get q. So qi is going to be qi hat. It's going to be ni, which is the population in that region, times the probability of pi, which will be a function of the travel cost from that region, okay, which will be, as I write out, E times TCI negative 1.05. Okay, so this is my dP, or more specifically dTCI in this case. Now, last part, let me do the integration as example. So let's say it's P0 to P choke. Let's make using P hat, and I E TCI negative 1.05 DTC. Okay, so this part will be constant, so we can basically factor it out. So you can actually write out the integration like this. This step is basically using the integration of a polynomial. So the only part that we didn't know here is actually P R tilde, which is choke price. Okay, so how do you calculate the choke price at zero quantity? So, right. So basically that implies Q is 0, implies P is 0. So that's a problem in this case, because that means calculate something like log 0, which is not defined. So here let's say Q is 1, so the P becomes over 1, and the log P is just negative log Ni is going to be equal to 1 minus 1.05 log P tilde, and you know this number, you can calculate the P tilde from here, and that basically concludes the whole travel cost model. And for this calibration, you can actually just using ORS. That will be fine.